Hello Legacy Sabers, Marsh here. So today we're going to talk about what does it mean to be similar. We've kind of been talking about proportions right now, so now we're going to kind of expand upon that and talk about why do we need to know about proportions. So what does it mean to be a similar shape? What you're going to want to have on you, calculator, especially one that can simplify some fractions for you today, pen or a pencil, and then also notes. So if I place this shape into the copy machine and reduce it, so what it's going to do is it ultimately is going to do that, right? It's going to be the same shape, but it's going to look smaller. That is what's known as a similar shape. So if you want to think of similarity, it's kind of like when you have two people who look identical, like alike, but they're not exactly alike. Not twins, but two that look very alike. Two people who look exactly alike. So to make a smaller or larger version, nothing changes in angles. You don't add or subtract from each side. The only thing that works is to divide or multiply by a certain number, aka you basically are keeping the sides proportional to one another. Because if I would send something through the copier, it's not going to look extremely out of whack from what it was originally. It's going to look relatively the same, even if I increase it by 500%. It's going to look like the same picture I sent through the picture copier. So let's talk about the definition of similarity in the math world. If something is similar, or two shapes are, we know that the angles of the shape are going to remain the same. So if I have a 30-degree angle, a shape that's similar to that shape will be also a 30-degree angle in there as well. And your sides are proportional, aka they have the same ratio to one another. If two polygons are similar, then the ratio of the lengths of the corresponding sides are what's called a scale factor. And usually when we find to see if things are similar, we're going to find the scale factor first to see if they're similar or not. So let's try the first example here. We need to find the scale factor first to see are they similar or not. What that means is putting each side of the shape over each side of the shape just to see are we going to get the same fraction. So I'm going to go x to y over q to r. So that's 6 over 4. That does simplify. Divide them both by 2. That would be 3 over 2. Now let's go 15 over 10. See if that simplifies down. Both divisible by 5, so that'd be 3 over 2 as well. 12 over 8. Both divisible by 4. That's 3 over 2. We're in luck. It looks like we're going to be good. And then I have 9 over 6. Now notice, guys, I'm starting on the bigger guy, going to smaller guy. I could go the other way around as well. As long as I do not tell you which way to go, it doesn't actually matter. But make sure if you stay one way, you go the same way each time. I'll be 3 halves as well. So it looks like my scale factor from XYZW to QRSP is 3 halves. That would be my scale factor. Now, what does it mean by a similarity statement? You guys last semester wrote a congruent statement. Similarity looks exactly the same. So I'm going to start with my first shape, X, Y, Z, W. Now, earlier you guys would have wrote the little equal with the new over there, with the little wave over. Now, similarity. Similarity is just a little guy, little wave. That is talking that you are similar. Something to keep in mind. Now, I went X, Y, Z, W. I have to do the exact same thing on the little guy. So that would be Q, R, S, P. That would be my similarity statement for those two shapes. Now, let's see, are the rest of these similar? So I have, it looks like I gotta kind of turn this guy around, right? Because this angle is matching to that angle. So it looks like PQ matches to LN, right? If I kind of spin that in my mind. So I'm going to go 4 over 12, which simplifies down to 1/3. Let's see if the rest of them also go down to 1/3. So it looks like QR relates to LM. So that would be 9 over 10.5, which that is 0.86. That does not simplify down very nice. You know what? These two guys are not similar shapes because all sides must be proportional to the same amount. If they're not, that's not going to work. You need to make sure all of them are not similar. Same thing, I could have gone 12 over 18, divisible by 6 on both of those. You would have gotten 2 over 3. That's still not similar to 1/3. So they all have to be by the same scale factor or same ratio. Let's try another one here. So looks like if I would kind of rotate that, 10 and 15 would be related. So that would be divided by 2 or 5, excuse me. That'd be 2 over 3. And then I started at 10, so I'm going to go 3 over 8. Which doesn't simplify. So, not similar at all. Not at all. They need to be similar. Now, what about when I'm told things are similar? So notice here, guys, I am told these are similar shapes. So what does that mean? I can find the scale factor. Basically, setting each side over each side. I know that 9 and 15 are the same thing. So I can find the scale factor by doing that one. Looks like they're both divisible by 3, so that'd be 3/5. So my scale factor is 3/5. Which means, if I look at this next one, find the length of TW. So they want me to find this length right there. I can actually set this up. So my scale factor, I can go 3 over 5, which would be then 9 over 15, but I just simplified it down. And then 6 over x. Like that. So I should be able to cross multiply. So I will get 3x equals 30. Divided by 3. Looks like x is equal to 10. So I know this measurement right here is 10 on my trapezoid. That's what that would be, is called a trapezoid. Let's keep working with this idea. So if I know these two triangles are similar, can I find the values of x and y? So it looks like I'm going to set small triangle over big triangle. I'm just going to make a little note to myself. Small over big. So I'm going to do, let's say I want to solve for x first. So I'm going to go 6 over x. I can't go 8 over y, right? Because then my x and my y are going to stay in the equation. I'm not going to be able to solve. So let's go 4 over 6. Like that. So multiply my 6's, I get 36. X times 4, that's 4x. Let's divide by 4. So I know that 9 equals x, so x equals 9. Got the value of x. Now let's find the value of y. Looks like 8 and y are related, so 8 over y equals, and I'm going to set it up the same thing, 4 over 6 as well. So basically finding the parts that relate to one another. 8 times 6 is 48. Y times 4 is 4y. Looks like I need to divide by 4. So I get y equals 12. So x equals 9 and y equals 12. Last one of the video. So we need to find the length of the altitude PS. Now you're probably saying, what's the altitude, Marsh? What is that? Well, ultimately what an altitude is basically the height of it. It's this thing right here, this drop down line right there. Sometimes you might hear words being used. That's called an altitude. It needs to hit down here. It does cut the base of my triangle into half, and then it becomes a right angle where it hit. So keep that in mind if you ever heard the word altitude. Once we talk about the special parts in a triangle, you will hear about that a little bit more as we keep going. So let's set it up. We do know these two shapes are similar, though they don't tell us, but they are. Let's go ahead and set it up. So Let's try big over small. How does that sound today? Big over small. So I got big is 20 over my small guy. He's X. We don't know how much his altitude is. And then we're going to go this side over that side. Now I could do the full side, so that would be 16 over 12. That would work too. But I'm just going to go 8 over 6 because those are proportional as well. So 20 times 6, that is 120, equals 8x as I cross multiply that side. Divide by 8. And I get x equals 15. So my altitude, PS, is 15 units long. And that's the end of this video. See you later, Sabers.